Good morning, class. Today is the sixth lesson for calculus. Um, we want to start learning how we differentiate trigonometric functions. Yes, we have the class side by side. The class is not all about high school, but as well for university students. All right. It's easy most times when our teachers ask us that what is the derivative for sine x? We usually say cos x. Yes, someone can ask you, if we differentiate cos x, what do we get? We say minus sine x. But in mathematics, we don't want to be doing things as if we memorize them. We want to prove everything. Yes, because it's worth it. So we want to show that when sine x is differentiated with respect to x, we'll be able to guess cos x. So in that case, if y is equal to sine x, we should be able to get what? Cos x. Okay. So the first thing we do, for every y we see, we replace it with what? Y plus delta y. When we see x, let us replace it with x plus delta x. So this is y. So what do we say? We say y plus delta y. Delta y. So we say sine x. What is x? X plus delta x. Okay. So having replaced y with y plus delta y and x with x plus delta x, what is the next thing we do? We subtract y from both sides. Do not forget the steps. We replace y with y plus delta y, x with x plus delta x. The next step is what? We subtract y from both sides. So on this side, we say y plus delta y minus y. We are subtracting y from both sides. This side, we've subtracted y. On the other side again, sine x plus delta x, let's say minus y. Okay, so minus y and y can go away. We are left with delta y. Okay, so this is sine x plus delta x minus y. But what is y? Y is sine x. So we say sine x. Okay. So what do we do here now? We have something like this, delta y. So if we divide both sides by delta x, it will appear like this. Delta x, delta x. Yeah. So we divide both sides by delta x. Okay. So now this keep being delta y over delta x. But this one happens as delta. Okay, now let's say we have delta over delta. Maintain it for now. So, but what is sine of x plus delta x? But writing delta x all the time, it seems confusing or we struggle a bit when we write it. So why not changing delta x to h? Yeah, sometimes we do that. And there are textbooks, there are authors, you no longer use delta x. They use h to represent delta x. Though that h is used to understand that it is delta x. And when you say delta x, small amount of x, very small. Okay, so now we say delta y over delta x equal to, now let's take the limit. The limit as delta x approaches 0. The limit as delta x approaches 0. So therefore, what do we go? So once we say delta x approaches 0, we can say, we can take the total derivative, which is dy dx. So the limit as delta x tends to 0, we have this one here, sine of x plus h. Remember, h is delta x. But if you think you can be writing delta x, no problem, it's just the same. minus sine x over h. Okay, but let us try to know what is sine of x plus h. Now let us go to compound angles. Compound angles, we understand that, oh, this one is sine. Compound angles, we understand that sine of a plus b is equal to sine of a cos b, we maintain this, plus cos a sine b. What is the pattern here? This sine starts and ends. Cos is between sine and sine, but still the order of the letters is maintained, AB, AB, and we maintain the sign. So therefore we say the limit as delta. Now we have decided to be using H. So, okay, no problem. Let's say H approaches 0. Okay, so what is sine of x plus H from what we've learned here? This is equal to sine x cos H plus cos x sine H. Just this one is expanded like this from compound angles. Okay, now we continue with minus sine x over H. Okay, so see what we have. There is nothing come between this and this, but there is something come between this and this. There is sine x, will bring them closer. So the limit as H approaches 0, now this is sine x cos H, bring this one, minus sine x, we'll write this one now, plus cos x sine H over H. So be attentive, the limit as H approaches 0 or H tends to 0 is just the same. So what is common here? Sine x. So sine x takes away sine x, leaving cos H minus sine x into sine x is 1. Then this is plus cos x sine H over H. Okay, so now let us remember something from limits, limit of function. If you have the limit of x as x tends to 1, we can say 2 times 1. The limit of 2x as x tends to minus 3, you can say 2 times minus 3. But the limit of 2p as x tends to 1, it is the same as 2p. Why is it the same as 2p? Because this x does not appear here. So because this x does not appear here, the limit of 2p as x tends to 1 is just the same. So in that case, okay, so in that case, the limit of sine x as h tends to 0 is the same as sine x, because sine x does not contain h. So therefore, what do we say? We say sine x, be attentive, sine x multiplied by this one now, cos h minus 1. This one now contains h. So now we say the limit of cos h minus 1 all over h plus, okay, here again, cos x does not contain h, but sine h contains h. So this one is out, we say cos x multiplied by the limit of sine h over h. Why this one has h? This one has h because if you have 4 plus 3 over 5 is the same as 4 over 5 plus 3 over 5. So if the whole of this one has h, you can say this divided by h plus this divided by h. So this cos is here. Why this cos is separated? Just to make things easier, because this cos x does not contain h. So this one contains h, so it is standing with the limit. So this one again contains h, it is standing with what? The limit. So this is what we have. Mind you, this is the result that we're supposed to get. So what do we do now? Here we have sine x. Whenever you have a pattern like this in limits, as h tends to 0, as h approaches 0, tends to 0 approaches 0, no problem. Tends is just like it is often used. But when you say this one tends to 0, it means h approaches 0. It is almost 0. Okay, so sine x is this one. Whenever cos of an angle minus 1 over this same angle here, and the angle approaches 0, the whole of this term will become 0. So if the whole of this term will become 0, so it's like we have sine x times 0, and this is plus. The limit of sine of any angle over the same angle, and that angle approaches 0, that one will always give us 1. So now we say cos x, this one times 1. So sine x times 0 is 0, plus cos x times 1 is cos x. So what does that imply? It implies that the result is cos x. So therefore, the derivative of sine x is actually equal to what? Cos x. And of course, you've seen it when we apply limits to derive that one. Do not forget these two cases. Cos of an angle, let me say cos x minus 1. Yeah, look at x. Okay, in fact, I don't need to use x because they don't mean the same. This h is representing delta x. Yeah, cos of an angle minus 1 over the same angle, but that angle approaches 0. This one is 0. Sine of an angle over the same angle, and the angle approaches 0. That one is equal to 1. So we are able to get cos x as the final answer. Thank you for watching. Do not forget to follow, like, share, and comment. Then see you in my next video. And lesson 7 is going to be how we derive cos x to get minus sine x. Bye bye.